what we're doing in the UK, we're running a study called the ADAM study, which is a large genome-wide association study, which is trying to understand whether the genetic risk factors for MS are the same for everyone, whether they're the same across different ancestral and ethnic backgrounds. And so what we're doing is we're recruiting a large number of people with MS from diverse backgrounds, and we're basically genotyping people. We're asking people for a saliva sample. They send it to us in the post. They can do it all from the comfort of their own homes, and we process it in our lab, measure hundreds of thousands of DNA variants from their saliva sample, and then compare that with lots of people who don't have MS. And the aim here is that we're going to try and build up a genetic map of how changes in DNA influence the risk of MS across lots of different diverse ethnic and ancestral backgrounds. I think the most likely impacts, or the most tangible benefits, are going to take quite a few years to realize. So it's important to say that genetics is at the more basic end of scientific research. And so translating the findings from genetics into meaningful benefits for people in the real world can take a long time. We're talking decades. But what I hope is that it will potentially lead to new drug targets by helping with fine mapping and showing new mechanisms. It will help with prediction, and that might help include more people from diverse backgrounds in prevention studies as well. And as I said, it might help shed light on global trends in the epidemiology of MS. So if we can prove that actually the genetic basis is very similar across ancestral backgrounds, that makes a strong case for going to countries where healthcare services aren't as well developed and helping to make sure that we're not missing lots of MS in those countries. So I think lots of tangible benefits, but all quite a long way away and all dependent on the success of our study and studies like it.